Welcome, dear students. We are learning some techniques to solve some of the numericals and the problems which are linked with current and electricity. Now, here we are. This is the first problem which we are discussing now, and it is a battery has an EMF of 12.8 volt. 12.8 volt and supplies a current of 3.2 ampere. What is the resistance of circuit? How many coulombs leave the battery in 5 minutes? So EMF of the battery is 12 volt, 12.8 volt. The current through the battery, that is 3.2 ampere, and the EMF is 12.8. The time through which the current passes through the battery, leave the battery, that is 5 minutes, and it is converted into second. Now you are asked to calculate magnitude of the charge. What is the resistance of the circuit and the magnitude of the charge? First of all, we calculate the resistance. Here it is so many coulombs, means how much charge leaves the battery, and the second one is the resistance. If you look at this, is by Ohm's law, we use a formula that is V is equal to IR. Here is I, and here is EMF of the V, that is 12.8. So to calculate the resistance, 12.8 divided by 3.2, and the resistance is 4 ohms. So similar is the case to calculate the number of the charges, and to calculate number of the charges, it is charges flowing per unit time. And by if you have the value of the current and you know the how much time it takes to pass the current, and then you can calculate the number of the charges passing by multiplying the value of the current, that is 3.2, with the time taken, that is 300 seconds. Now the number of charges flowing through the battery, that is 960 coulomb. So this is the technique. First of all, if you are asked to calculate the EMF is given, current is given, then you can calculate the resistance. So you have calculated the resistance at any case. So the next one is number of the charges passed. So to calculate the charges, you have to use a technique that is use the basic definition of the current, that is charges flowing per unit time. And if the time and the current is given, then you can calculate the charge. But similar is the case if you are asked, if the charges are given like 960 and the time is given, that is 300, you are asked to calculate the current passing, you will be getting same value, that is 3.2. So these are the techniques used to solve some of the problems, to some of the numericals. So in this numerical, what you have learned to calculate the resistance as well as to calculate the number of the charges flowing through the battery. So here is another problem. Carbon electrode has a resistance of 12.125 ohm at 20 degrees Celsius. So this is the temperature at 20 degrees Celsius. The resistance, the coefficient of resistance, the carbon is 0.005 at 20 degree. So what will be the resistance? What is the resistance of electrode at 85 degrees Celsius? So at such resistance you are asked to calculate. It's also a very simple type of the problem where you have to calculate the resistance at such temperature. So this is the formula which we'll use, but for this formula, resistance at 0 degrees Celsius, so the low temperature is not given. So first of all, we will calculate the resistance at low temperature, that is R0. So this R0 is equal to the resistance at 20 degrees Celsius, that is 125, and 1 plus coefficient of resistivity, resistance and the temperature. This is the temperature is 20 and coefficient of carbon is 0.005. So 0.005 is the coefficient of resistance of a carbon. So after putting the values in this formula, this is the temperature. This one is the value of the resistance as 20 degree. And after getting the value of the resistance as 0, that is 0.125 divided by 0.99. And if you divide it with 0.99, you are getting resistance that is at low temperature, that is 0.126 ohm. So now the resistance at 85 degrees Celsius, first you have calculated the resistance as low. Now you are calculating resistance at 85. 85 resistance at 85 is R naught, that is 1 plus alpha T. R naught you have already calculated the resistance at low temperature. So putting the values, coefficient of resistance and value of temperature, that is now it's 85. You have placed the value of the temperature at 85. So putting the value and finding the difference, then after multiplying these two, 85 with 0.005, you got 0.0425. So here you are. If you multiply outside its bracket, if you multiply these two, the resistance of the conductor at temperature 85 is 0.12 ohm. So this was required to calculate. If you look at back again, the carbon electrode has a resistance 0.125 at 20 degrees. So its resistance at higher temperature. The temperature coefficient of the carbon is this one at 20 degrees Celsius, means at the same its resistance coefficient of resistance value is this one. What will be the resistance of the electrode at 85? So you are asked to calculate the resistance at 85 degrees Celsius. So first of all, you have to calculate and find out the formula. Here is the formula to calculate. But to calculate resistance at 85, you are not having the resistance at low temperature, that is R naught. So first of all, you have used this formula to calculate by using 20 degrees Celsius. This is the higher temperature. So you have calculated the resistance at that temperature. When you have already calculated, so resistance at zero, so you have used the technique to calculate the resistance at higher temperature, because this is the formula which gives the effect of the temperature. With the increasing temperature, the resistance of the conductor also increases. So that's why this formula is used. With the increase of the temperature, the resistance will also increase. So this is the formula which is used to calculate. So by using this formula, you have calculated the resistance at 85 85 degree Celsius. So with this, I thank you very much. I hope you people have understood.